new chapter, chapter 7. It's statistics. We shortened it up. It's stats. 7a is permutations and combinations. Quick definitions. Permutations are an arrangement of items in a particular order. Permutation is also, it's an ordered combination, specific order. Here are some examples. Playing pool. You can only, once you make a ball, you can't make it again. Sorry, it's off the table. Specific order. Lock combination. We call it combination lock, but it's really not a combination lock. It's a permutation lock. The order that you put into the lock matters. If your order that you need to put in is 40, 30, 20, you can't enter it in as 20, 30, 40 to open the lock. So this permutation. Order does matter. Combination is you're selecting which the order does not matter. You're choosing random items. And some examples here are the lottery. Does not matter when you have 6 lottery numbers. It doesn't matter the order that they are drawn, just that the 6 are drawn. Selecting a group of people is very general. Combinations tend to be very general. Selecting a group of people. Or selecting a toppings on ice cream. Doesn't matter which order you put the toppings on, it tastes all the same. One other example from permutation was running a race. It matters the order, first, second, third. It matters the order that you place when you do a race. Another thing you need to know is factorials. So this is called 3 factorial here, 3 factorial. Way to write it out is it's just 3 times 2 times 1, which is 6. So the next one I have is 8 factorial. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And there's a button in the calculator that'll do this for us. It's under math key. Just helps turn the calculator on. Math key over probability and factorial. So to enter in 8 factorial, you do 8. Just so you can see it. Math, probability, down to factorial, hit enter. There's 40,320. That is 8 factorial. And you need to use the factorial key for permutations and combinations sometimes. Permutations, there's a really easy way to do this. It's in the calculator. And so we have, it's called NPR. It's in the calculator. It's under math, over a probability again, and it's NPR. N is the total number of items in the set, and R is how many you are choosing. R is items at the time. So let's get to some examples on permutations so I can better explain this. First one, how many different 9-player batting orders can be chosen from a baseball squad of 16? Now, baseball matters the order. If you're batting first, you're batting last, it matters. So what we do is there are 16 total people, so that's your N. Your N equals 16. I guess that's written over there. I need to write that. And then there are 9 at a time, so how you write this in the, put this in the calculator, you're going to do 16 P, and you're choosing 9. So in the calculator, you go to, so you write 16 first, 16, math, or PRB, NPR, and you choose a 9. Hit enter, and it's a really big number. 4, 1, 5, 1, 3, 4, 7, 2, 0, 0. 4,151,347,200 different batting orders. Another thing you might find out is, or a way to tell is, permutations. There are a lot more permutations usually than when you do combinations. So permutations, you see a lot more. Another permutation, this one's a big one, one I see quite often. Out of 7 people running for class office, how many different ways could president, vice president, and treasurer be elected? So this is saying like the biggest vote getter becomes president, the second highest vote getter is vice president, and the third one is treasurer. So there are 7 people total, and it matters if you're president or vice president, so that's permutation. And we're only choosing 1, 2, 3 different positions. So 7, choosing 3. So on the calculator, we do 7, math, or probability, and we're choosing 3 of them. There's only 210 different outcomes for this. Moving on, combinations. In a class of 23 students, I need to select 4 to help me with a project. How many different ways could I select these 4 students? In this problem, the order of the 4 chosen students do not matter. So it doesn't matter if you're chosen first in that group, and this is one way to tell combinations. It's always very vague, very general group of 4 students. It doesn't matter if you're chosen first in that group of students or you're chosen last in that group of students, just as long as you're in that group. It doesn't matter the order. There's nothing, no specialty, nothing for chosen first to chosen last as long as you're in the group. So in this case, we have 23 students. So you can see down here, 23 students, and we're only choosing 4 for the group. So it's 23, and it's a combination of 4 students. And again, calculator, we go to type in 23. And some calculators might be a little different, but with how you type it in. But to find the NPR and NCR, it's same place, math over to PRB, so, and then in this case it's NCR. So, and then we're choosing 4, and there are 8,855. Those different groups that you can choose. Sometimes we get into, you have more than one combination or more than one permutation. So for this, for a band camp, you can choose 2 or 3 roommates from a group of 25 friends. And how many ways can you choose? So you have 2 different scenarios here. You have two roommates, or then the other scenario is 3 roommates. So we do these separately. So we have choosing 2, that's a group, so that's 2, and we're choosing them out of 25 people. And then we have also, that's scenario 1, and then we have scenario 2 with, if we had 3 roommates, so that's 3 roommates, group of 3 people out of 25. And then we have this word or. Whenever you see or is adding. So we're adding these together. So this will give us all of our combinations added together. So when we figure this out, put this in the calculator. We have hopefully you saw I switched it now. I made a mistake. Shocker. Yeah, it's the time. I'm supposed to put the total number that you can choose from first. So 25, choose 2. I switched this around here. Choose 25 and you choose a 2, and 25 and you choose a 3. Now when you enter it in the calculator, you can enter it all as one problem or separately. The top here, I did 25, choose 2, That's 300, and then I did 25, it's a combination choosing 3. That's 2300. And you can obviously add those together, and you get 26. Or you do it all together, which is the last line here, I did 25. It's a combination of choosing 2 plus 25, your combination choosing 3. Together you have 2600 total different combinations of roommates. So it's 2600 combination of roommates. If you want to pause it right now and try to figure out, is this a permutation or a combination? It's a good time to do it. Otherwise, let's dive into it. We have a salad bar offers 8 choices of toppings for each lettuce. How many ways can you choose 4 or 5 toppings? So here we have, we're choosing 4 or 5, very vague. Those are groups of toppings. So we have that this is a combination. There are 8 total, so it's 8 combination. We're choosing 4, and or, I see an or, so that's plus. The other one is and is multiply. We're not going to get into that today. The other one is we have 8 total choices, combination of choosing 5 of them. So let's do this. So I did it on the calculator, it's a combination, and there's 126 different topping choices, or 4 or 5 different toppings. 126. So if you want to pause it and try to figure out is this a permutation or a combination, it'd be a good time to do it. And I'll tell you in just a second. Alright, there's a second. This is permutation. 15 students asked to visit the admissions of representatives from state university. Each visit includes 1 student. How many ways can 10 time slots be assigned? Alright, for this is permutation. There's 2 different ways I'll solve this problem. It is a permutation. The easiest way is there's 15 total, or it's permutation and you're choosing 10 time slots. So you can do it that way, or you can do something like write out each time slot. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 time slots. How many people can possibly, or how many people want to be in that first time slot? Well, there's 15 total. 1 person actually gets that time slot, so then how many people would be left for the second time slot? 14. How many people would be left for the third time slot? There's only 13 people left because there are already 2 people that went. After the third time slot is gone, there's only 12, 11, 10, 9, 8, 7, 6. If you multiply all these together, it's the same thing as doing 15. P10. So that's kind of like a permutation or a factorial. Do this in the calculator, and it is a massive number. Anytime you see that e in the calculator, that's an exponent. The scientific notation 1.0897284 times 10 to the 10th power, which is really huge. Move the decimal place to the right 10 spots. So it's really, really big. Many different ways of filling up these 10th time slots. You could also do the 15 times 14 times, I'm not going to bore you anymore, all the way down to 6. That would work. So hopefully you got something out of this. Come to class, ask questions, I'm sure you'll have lots. And sorry for this being 14 minutes and 23 seconds.